Okay, going to look through the level 2 exercise now. So the first one is telling you the gradient, and it's wanting you to find the equation of the curve. So that's finding y equals. So standard integration, add 1, divide by it, add 1, divide by it, and don't forget your c. And you're told x is 1, y is 2. So sub them in to get your c, just as before. Rewrite your equation using your c. And then part 2, it says find the value of y when x is 3. So you just put 3 into your y and work it out. Question 2. It doesn't give you dy by dx in question 2, but it says the gradient is given by this. So that's assuming that you remember that dy by dx equals that expression. You see, we have multiplied out the brackets. So, and then it's wanting me to find, given that the curve has a maximum value of 8, okay, find the equation of the curve. So first of all, find the equation of the curve. Let's integrate it first of all. So integrating that, x reappears, add 1 to the power, divide by it, and don't forget your c. Tidy that up. Now, the question said it had a maximum value of 8. So that meant its turning point. Let's think about this. The turning point is when dy by dx equals 0. That's your maximum value. So your dy by dx put equals 0, x is 1. And you're told it was a maximum when y was 8. So you've got a point there. X is 1, y is 8. Sub that into your y equation to get your c. Rewrite your equation using your c. That's quite a tricky wee one, to be fair. Let's look at question 3 now. Find an expression in terms of y if dy by dx equals that. So first thing we'll do is multiply that out. So I've written dy by dx, multiplied out the brackets, tidied it up, integrate, add 1 and so on and so forth, tidying up. Then you're told y is 2, x is 1. Sub them in to get your c value. C is naught, so just rewrite this equation and put c to be naught. So that wasn't as bad as question 2. Question 4. A curve with gradient of this has a local minimum value. Okay, let's think of that. Minimum value is a turning point again. Find the equation of the curve. Let's get that done first. So you've got dy by dx, integrate it to get your y. Okay? Put your e plus c on. So minimum is when you've got a turning point. It's the same as question 2. So dy by dx equals 0, work it out. You get x to be a half and minus a half. Now you're told it's a minimum. Reading the question. Sorry, it's a minimum value of 1. So first I have to work out which answer I'm going to choose here, because one's going to be a maximum, one's going to be a minimum. To do that, do your second derivative. So differentiate again. When x is minus a half, putting it into here, the second derivative is a maximum. When x is a half, the second derivative is a minimum. And your question is wanting the minimum. So I'm going to choose this, x to be a half. And it tells you that the minimum value is 1. So when x is a half, that's when it's minimum, y is 1. Okay, so I'm subbing that in to my expression here. So when x is 1, y is a half to get your c value. And the question then, it's a very, very difficult question. The question wants the coordinates of the maximum value. So I know that the maximum value occurs when x is a half. So, sorry, minus a half. Sub this minus a half into your y equation. So that's what I'm doing here, is my y equation. And your c value is 4/3, so use it and working out your y. Very, very tricky question. We'll just go over the main points of that again. Gradient, integrate to get y. You were told the minimum value, so it was turning points. But when you worked out your turning points, putting dy by dx equals 0, you got 2 answers. You didn't know which one to use. So you had to go over to the side and do second derivative. Work out which one was maximum and work out which one was minimum. So when x was minus a half, it was a maximum. And when x was a half, it was a minimum. The question is talking about the minimum first of all, so I'm looking at x a half. When x is a half, the question tells you that the minimum is y, is 1. Sub that in to get your c value. And then you want it to work out what the maximum was. The maximum was when x was minus a half, you've worked out over the side. So you sub that into your y equation and you now know your c value. and you take it from there. Very tricky. If you're not getting that question, I wouldn't be too worried about it, because that is definitely a hard question. Question 5. You've got your gradient. It's got a maximum point. Find k. Okay, let's just do something with that. Integrate first of all and tidy up. Now your tool has got a maximum point. So put your differentiate it and set it equal to 0. So just checking here, I think I made a wee mistake there. Yep, and just fix this now. So dy by dx equals 0. So 3x squared minus 2x add k equals 0. And you're told that it's got a maximum point x equals minus 2. So x equals minus 2. So working this out, minus 2, sorry. So I jumped ahead of myself there. So 4 times 3 is 12, plus 4, oh sorry, I had made a mistake. So k is minus 16, sorry. Should have left that in there. Right, so I've got the k to be minus 16. You're told then that the curve goes through 1, 3. That gets you your c value and find the equation of the curve. I was thinking there was going to be 2 answers there when I saw that dy by dx. But then you were told what the x coordinate was, so it made it a lot easier.